All right, let's look at some complex circuits. So combining the idea of series, excuse me, and parallel components. So if you're looking at a complex arrangement, you can simplify by combining elements, small chunks of elements, into equivalent resistances until you get one ultimate equivalent resistance. And we're going to look at one example of this. So what's the equivalent resistance of the circuit below? So the way that we kind of do this is you just have to sort of build an eye for like where is a pair that are nice and simple to work with. So maybe take a second and look at where's 2 or 3 elements that are either all in series or all in parallel. And I'll give you a hint, there's actually 2 places that you can find that. So pause, see if you can find the 2 sets of components that are all in series or all in parallel. So what we can see here is that R2, 3, so R2 and R3 are in parallel with or in series with each other. So that means that's going to be R2 plus R3. And we can also see that R4 and R5 are in parallel with each other. So I can write that that is 1 over R4 plus 1 over R5. So let's calculate what R2, 3, and R4, 5 are. So R2, 3 is an easy one to calculate. That's just 80 ohms. R4, 5, that's going to be a little bit of a pain, so let's get out a calculator. It might end up simplifying nicely, but I'm not seeing it. It's something I can do quickly in my head. Okay, and that will give us 7 over 180, which means that R45 is the inverse of that, which is 180 over 7 ohms. So now we've got a circuit that I can redraw. I'll redraw it down here. So we've got R1. And then remember we combined R2 and R3 up here, so I'm going to call that R23. And then down here I've got R45 and R6. So does that kind of make sense how we'd be able to combine small chunks of this? Now if you look, can you pick out the next chunk that we'll combine? Take a guess. And what we will be combining next is R456, so R45 and R6. And that one, those are in series, so they just add together. So 20 times 7 would be 140, 140 plus 180 would be 320. Over 7 ohms. So now we have an R456, so I can rewrite that, redraw that as R1, R23, R456, and now you'll notice R23 and R456 are in parallel, so that's 1 over R, we'll call this 1 over R2, 3, 4, 5, 6. And you could use other ways of representing it. For me, I kind of like this. It's usually useful, sometimes it's not, but it helps me track where I'm going, and you can see it gets kind of complicated though. So this will be 2, 3, so 1 over 80 ohms plus 7 over 320 ohms. So that will give us 11 over 320 ohms. So that means R 2, 3, 4, 5, 6 is equal to 320 over 11 ohms. I don't believe that simplifies yet. But now we have this is our illustration, so our total will just be the sum of those. So 75 ohms plus 320 over 11 ohms, which I don't think I can do that quickly and easily in my head, so let's calculate it here. So that is 104.09 repeating. Or if you want to write it with fractions, 104 and 1/11 ohms. So that kind of gives you an idea of how we can combine these together. And again, it's just looking for clusters or chunks that we can combine easily. And when you practice this, you're going to do it, you're likely to do it wrong as you get practice, and that's something that there's just little nuances that we'll have to correct, but that's why I want to kind of give you an example, and we'll go through a second example here. What's the equivalent resistance of the circuit shown below? And we've got all of these going on here. Now, this one is a bit complicated and confusing because of how it's drawn out. So the trick with this one is redrawing it a bit. And what we notice is, as you look at it, we want to think about where the current can flow. So it can flow either, as it comes along, it can flow through the top path, it can flow through the kind of middle top path, it can flow through the middle bottom path, or it can flow through the bottom path for the start. So that means these first four right here are all in parallel. So I'm going to draw them in the way that we're a little more used to seeing. So now, if it went through the top path, it's going to come out. It's done. So we're going to come out here. If it goes through the top middle path, it's going to come out and it's going to be done. If it goes through the middle path, though, or the bottom middle or the bottom, those can come back together because then it can choose to either go through the bottom or the top or the middle bottom. So these come back together and then they split again. And then they come back together and leave. So these two circuits are equivalent. Again, we just kind of, how we figured that out was thought, okay, when it comes to this first branch, what are all of its options? And then we simplified that branch to what we're used to seeing of having them kind of all in parallel like this. Then we saw, oh, there's another branch right here, and another branch right here, so this can branch, these come back together, and then they can branch either way. So let's start combining things. Take a look and guess what you think would be the first thing you would combine. Okay, so the first thing we want to combine are both of these parallel circuits on the bottom. And if it's a little hard to see why, imagine this actually comes out and goes in like that. So then we're going to have a three-step ladder ultimately, but we need to find out what the bottom rung is first. So nice that both of these are the same. So 1 over the equivalent resistance will be 1 over 50 ohms plus 1 over 50 ohms, which is going to equal 2 over 50 ohms. So that means the RT is equal to 50 over 2 ohms, which is equal to 25 ohms. So in other words, we can rewrite this or redraw this like so. (100 ohms on the top, 100 ohms on that middle path, and then two 25 ohm resistors on this bottom path. Again, just from doing both of these in parallel. Now these two on the bottom we're going to combine in series, and I think it's easy enough to see 25 plus 25, so I'm just going to straight redraw it with our known equivalent resistance. And on the bottom, we now have a 50 ohm equivalent resistance. And now we have to combine all three of these. And actually this is on the circuit of the section. That's just a clarity because this isn't actually a circuit because we don't have the two ends connected. Combining these, 1 over RT is going to equal 1 over 100 plus 1 over 100 plus 1 over 50. The 50 I can write as 2 over 100. So 1 over RT is going to equal 1 over 100 plus 1 over 100 plus 2 over 100, which means I get 4 over 100 ohms. That will equal 1 over 25 ohms. So that means RT is equal to 25 ohms. So if you combine all these together, you could replace them with a single 25 ohm resistor. So that's the idea behind simplifying these more complex circuits. I won't expect you to do a lot of this in this class, but I do want to have that idea planted because it is something that you would be expected to do kind of in a next level physics course.